So, now to the proof of why the I operator is true. So, the proof will later be on an apple bong, meaning you punch two black ideas into an apple bong, better set into an apple and make a bong out of it. Meaning, if 0 plus 0 plus, if 0 equals 0 plus question mark in case of I times x equals 0, then e square 0 equals x times minus I. Why do I say this? Because meaning matrix of e square minus x equals minus 1 and e square minus 1 equals minus 2 and e square 0 equals minus x. That's the same matrix as x square minus 1 equals 2, x square minus 2 equals 1, and x square minus e square minus 1 equals x. If x is a variable, then I equals x by this definition. Now to the proof, the mathematical proof, to the apple bong. If this true or any meaning, then if calculation true, then smoke of an apple bong always measures up to the degree of closure of lighter to the bong cake, meaning the pinch plug. Why? Because volume is x times square equals y. And if x times I equals matrix of x square minus 2, right? Meaning e square minus 1 equals minus 2. Or x square minus 2 equals 1. Then y of x2 is the same, but of square of y2 x equals 1. Meaning e square minus x equals minus 1, or x square minus e square minus 1 equals x. Yep. Thus, square equals x is e square 0 equals minus x. Why? Because square of 0 of minus x equals e, square of 0 of minus x is undefined, and undefined equals e, meaning x equals I. Now, why are the matrices by this pattern proved to be the same, but also same of calculation, thus x equals minus e in case of I times x is the same matrix? Because if x, too many variables, 2 times x, too many times x, 2 times x, y of x square 2 is basically x square minus 2 equals 1. And as she already pointed out, thus square of y equals x is e square 0 equals minus x. And that's the third one down below. She pointed out why these are the same, and I pointed out before how they intertwine the matrices. And if that is true, then e square 0 equals minus x is undefined. Meaning e is then undefined and not defined anymore, therefore takes irrational qualities of variable if not summarized. And summarized then in variable definition, of course, but irrational. Thus, y square 0 of minus x equals e square 0 of minus x undefined. Therefore, if you now take into calculation that x square 2 is the same but of square of y to x equals 1, meaning the matrix, the second matrix, the second step, then if you calculate the to each other, e times square 0 or e square 0 equals minus x the x then minus, funny to say, calculated to the matrix of that equation equals basically that, wait a second, e square 0 minus x square minus 2 equals 1. And that holds true, right? E square 0 is 1 minus x, meaning e square 0, 1 minus 2 equals 0 equals 1. That is of course untrue, but if you now take into calculation what I said before, e square 0 equals minus x put into x, then you basically derive it down one step and use square of y equals x, meaning that y is the questioned variable by square of it, and by that definition you can, if e is undefined, cut x with the same equation that it has been presented with, meaning e times 0. That you do 2 times, and then you have 3 minus 2 equals 1. And 1 is equal to 1. And if that holds true in two matrices, I must at least if equal x has some value in case of defined. Now, to put that mathematically into calculation, x squared minus 2 equals 1. Again, sorry for the repeating. E squared 0 equals minus x, meaning minus e squared 0 equals x. Then e squared 0 with a minus in front of it, squared with minus 2 equals 2, and 2 then equals 1 again, which doesn't make much sense till you take the rest of the matrices into account. Meaning, if now you redevelop the formula to the same idea, meaning 1 equals minus x and minus 1 equals x, and you take into account the first step of the matrix, which we didn't calculate yet, meaning minus 1 equals 2, the matrix suddenly has 2 true points. And if then you enter both variables for both x, meaning discalculate variable x to 2 degrees, thus 1 square minus e square minus 1 equals 2, you start to maybe see the problem.